Hello and welcome to the fourth video of the Internet of Things in the production. What you see here is my little setup I used in the workshop at our place. And it's of course portable, so I can put it to any machine I would like. What you see here is a little power supply for the ctrlX core, then an Ethercat master, and digital in and the serial in. The digital in is hooked up with such inductive sensors, and the serial in, for this I got this very nice scale from MAR, which is a digital scale that data goes directly into the RS-232. Well, last time I told you I will say something about the possibilities we have for our machine running cycle and how to differentiate between good and bad parts. For the tool, the first thing I found out is we need some kind of a heartbeat. So we don't only need is the machine running or not, but we also need kind of, do we have a connection to our server, to our MQTT broker. And for this I integrated over Node-RED an MQTT small protocol that just says my ctrlX core is running and yes, I'm alive, I'm alive, I'm alive. So from this I know that my setup is running and connected. And the second part is how can we check if the tool or if the production is running, which is very simple. I hooked up this inductive sensor directly to the tool, as you can see here, and every time the tool opens and closes we got a 0 or 1 depending on open or closed, and from this we can calculate the cycle time, which then can be calculated and evaluated either through PoC or in the Node-RED, or what I did as well, check it on the server and get the cycle time on the server. The most precise value would be, I think, over PLC programming, because it's going directly to the core. So this was the easy part. So is the machine running or not? Of course, if we have some differences in the cycle time, we can push a signal and say something seems to be odd, please look for the machine, or the machine is not running anymore, we don't have a cycle time anymore, please check the machine. The harder part, of course, is scanning for good and bad parts. In the older machines we don't have a connection to the sensors of the older machines, so I had to find some new possibilities to get some data that we can use to differentiate between a good and a faulty part. And the first thing for me was the way of the main piston of the machine, and so the extruder, and I just hooked up this digital scale to the extruder, and the signal of course gets into the ctrlX core, gets evaluated there, and we can build up a graph that looks something like this. And what you can see is that it should be always the same positions when the molding process, when the injection process into the mold happens. So what we can do in our server is that we put a window over this graph, and then if the values are above or below this window, we also can say, okay, there might be too much force or too much material into the tool. This could lead to ridges, for example, or in the other direction, if the extruder is not going far enough. Of course, we could have voids or sinks, or the part is not fully built up into the tool. So this was the first and more easy way to check for good and bad parts. And the second would be the weight of the part, of one part. So when the part falls out or is taken out, we wait and see if there are differences to our correct and good part. And the third thing, and this would be one of the nicest, of course, to have an automatic optical control of a part, which means you place it somewhere or in different positions or rotate it, make pictures and video of the part, and then with computer vision see if you can analyze if there are some differences between a good and the bad part. For the first one, I integrated this with the digital scale and saw that it works pretty okay to see if there's some differences in the production process. The second and the third, so the weight of the parts and the optical control, I didn't have enough time to integrate it with the ctrlX core, although it would definitely be possible, because this is a very powerful tool. But in the developer challenge, in the time frame of the developer challenge, there wasn't enough time. I've learned from the ctrlX core what is quite important for you if you want to work with it. Check if you have always the latest software version, and also not only for the ctrlX core, but also for example a drive or the EtherCAD master, that you have the correct software version for every of them, and ideally the latest one. Because otherwise it could happen that you have incompatibilities and then things don't work out as you expect maybe. And the second thing is, although a lot of things are really good implemented in the ctrlX core right now, like in a graphical user interface specifically made for example a drive or a linear motor control or something like that. Some parts still have to be done in PLC programming, and from that I would suggest you, if you want to work with it, see if you need PLC programming and check it out. If you're comfortable with software development, PLC programming is not that hard anyways. It's just a little bit different commands, but in the end it should not be a problem. From my part of view, the ctrlX core is really a cool and a powerful and great tool with a lot of capabilities. You can do so much with it, with the drives and everything. You can do, I think, almost everything in automation technique with the ctrlX core. From that, I really recommend it, and also I recommend the team of Bosch Rexroth, which are very friendly, very helpful. Everything you want to have or need, or you cannot figure out, you can call them, you can write them emails, and you will get very fast answers, and they will help you out to find a solution to get you going on your way. That was my experience so far, and really liked it. So from that part, I want to say a lot of thanks to Bosch Rexroth that I could get the opportunity to go with the ctrlX core and make my first steps and see how my retrofit integration could work out. And I'm really happy and glad that I could work with the ctrlX core. And for the rest of you viewers, I would like to invite you to my next videos. I will go on with a little different setup, and I will build up a weighing station, which will take a little bit longer, and probably or hopefully an optical control as well, which of course you could hook up to the ctrlX core as well, because you have a USB connection here. However, and I would really like to invite you and go on with me to my way through the Internet of Things. What's left to say? Please like, please share, please follow me, and I wish you a nice day and see you soon. Bye.